Good morning, students. Today our topic is third law of motion. Okay, Newton's third law of motion. The first two laws of motion tell us how an applied force changes the motion and provide us with a method of determining the force. Okay, the first two laws, Newton's first law and Newton's second law, tell us how an applied force changes the motion. That is the first law. Okay, how an applied force changes the motion. That is first law. First law tells us about that if until or unless you are applied an unbalanced force on the object, you cannot change the state of rest, you cannot change the state of motion, you cannot change the state of direction. So we need an unbalanced force to change the motion. Okay, this is the first law. Now it provides us a method of determining the force. That is the second law. How can you determine the force? By using the formula F is equal to K MA. That is the formula for finding the force. If you know the value of K, M and A, K is constant here, M is mass of object and A means acceleration. By using this formula you can find out the magnitude of force, you can find out the value of force. Okay, these two lines suggest this. Okay, now we are talking about the third law. The third law of motion states that when an object exerts a force on another object, suppose this is a boy, okay, and this is another boy. Suppose the boy A applied or pushes the boy B, means he is applying force on him. So if one object exerts a force on another object, the second object instantaneously exerts a force back to the first. It means that if boy A apply force on the second boy, means second boy in return also apply the force. Means if we are pushing the wall, means the wall also exerts a force on us. If we are pushing a chair, means chair is also applying a force on us. Okay, but we cannot see the force. Only we can see the effect of force. We can feel the effect of force. So these two forces are always equal in magnitude, means its value, numerical value like 5, 6, 7, 5 Newton, 6 Newton, 7 Newton, means these are the magnitude, numerical value, numbers, and opposite in direction. What does it mean? This third law means when we apply force on any object, in return the same force, okay, with same magnitude, the object also applies force on us. Okay, that is the meaning of the third law. These forces act on different objects. This is very important point. Okay, these forces act on different objects and never on the same object. For example, like if you, this is the football, and if you hit this ball with your leg, so there are two objects, means one is football and second your leg. Okay, means we need two objects, and these are the forces we call action and this is reaction. Okay, any force you can also call the force applied by object, that is action and that is reaction. Any force you can take as action and reaction. So these forces acts on different objects and never on the same object. That is very important point. In the game of football, sometimes we, while looking at the football and trying to kick it with a greater force, collide with a player of the opposite team, means both feel hurt because each applies a force on to the other. That is the meaning of third law. Means the two objects apply force on each other. In other words, there is a pair of forces and not just one force. Means there is a pair of forces. The two opposing forces are also known as action and reaction forces. Like if we kick a football, means we are applying action force on the footballs, and the force by football on us, okay, that is reaction force. You can interchange the force, like you apply force on football, that is reaction, and football applies force on you, that is called action. You can call action or reaction force. Let us consider two spring balances connecting together as shown in figure 9.10. There is a figure 9.10 is given here, you can see. Okay, there are two spring balance, we just arrange like this. Now you see the two spring balance. Okay, it is observed that both the spring balances show the same reading. Means when a force is applied, understood this point? Okay, wait. Yes. Let us consider two spring balances connected together as shown in figure. The fixed end of balance B is attached with a rigid support. Means first spring balance like this. This is attached to rigid supports like a wall. When a force is applied through a free end of the spring balance, like one end is there, you is pulling this spring balance, both are attached. Then it is observed that both the spring balance shows the same reading, means they are applying same force. It means that the force exerted by spring balance A on balance B is equal but opposite in direction to the force exerted by balance B on balance A. Okay, any of these two forces, now you see here, any of these two forces can be called action or reaction, any of the forces. This is the third law of, this gives the third law of motion. You see here, in this two spring balance attached with each other, one end of this spring balance B is attached to the wall and this free end to attach with spring balance A. Then you pull this spring balance, you observe that both the forces are equal but in opposite direction. Either you can call it action force and reaction force, or you have option that you can just call it reaction force or this action force. It's your choice. This is the third law of motion. Okay, that is clear. However, this gives an alternative statement. This is clear, na? This is third law. This is third law. Okay, yeah, this is clear. However, it must be remembered that the action and reaction always act on two different objects. Okay, this is clear. Simultaneously means एक साथ, same time. Yes. Suppose you are standing at rest and intend to start walking on a road. There are some examples to elaborate the third law of motion. First example we will discuss about the football, the second spring balance. Now third example. Suppose you are standing at rest and intend to start walking on a road, you must accelerate and this requires a force. This is the second law, means we need a force to move, means to accelerate. What is this force? Is it muscular effort you exert on the road? Yes, it is muscular. Is it in the direction we intend to move? No. We intend to move in forward direction, but we are applying the force in backward direction. Why? Because we are applying force in, no, you push the road below backwards. Okay. We are not pushing it forward, but we want to move in forward direction. The road exerts an equal and opposite force on your feet to make you move forward. Means you are applying force backward, the road applying force forward. So this is the meaning of the third law, action and reaction force. And don't be confused here, both forces are equal, then why the object is moving? Okay, because it acts on the two different objects, and mass of the objects are different. It is important to note that even though the action and reaction forces are always equal in magnitude, these forces may not produce acceleration of equal magnitude. That is also important. The forces may not produce equal magnitudes. You are applying the same force, object first on object second and object second to first, opposite direction. So why we take minus here, means they are applying the 100 Newton force, but these velocities are different. Means, for example, like if you fire a bullet from gun, then you see the bullet covers a long distance, but the gun slightly moves backwards, not the same distance. The velocity of gun, the acceleration of gun is less, and the acceleration of bullet is more, but they are applying the same force. Why? The acceleration are different. Why they accelerate differently? So you see, because each force act on a different object that may have a different mass, because they are having different mass. Gun having more mass, so it accelerates less, and bullet having less mass, so it accelerates more. Okay, when a gun is fired, it exerts a forward force on the bullet exerts an equal and opposite force on the gun, that is action and reaction force. This results in the recoil of the gun. Means the gun move back. Recoil means move back. Since the gun has a much greater mass than the bullet, the acceleration of the gun is much less than the acceleration of the bullet. It is because of the different masses. Okay. The third law of motion can also be illustrated when a sailor jump out of a moving out of a rowing boat. Okay. As the sailor jumps forward, the force on the boat moves it backward. Okay, you see here in this picture for bullet, now you see this is the two opposite forces are there. Wait. Okay, equal and opposite. Now you see in this figure you can also see that the sailor applying the force in backward direction, and in turn this boat applies the force in the forward direction. This is action and reaction. This is third law of motion. 9.4 activity. We need 2 children for this activity. Require 2 children to stand on 2 different cards. Give them a bag full of sand or some other heavy objects. Ask them to play a game of catch with the bags. Does each of them experience an instantaneous force as a result of throwing the sand bag? You can see. You can paint a white line on the cart wheel. Observe the motion. You see, suppose you just make a line here. Okay, just draw a line here. Okay, you see this boy throw this sandbag, then this cart move back. When this girl throws this bag, then this cart move back. Means they are action and reaction force. Now place 2 children on one cart and another cart. The second law of motion can be seen, as this arrangement would show different acceleration for the same force. Okay, because of the mass. The cards shown in this activity can be constructed by using construct by using a 12 mm and 18 mm thick plywood board about 50 cm 100 cm with 2 pairs of hard ball bearing wheels. See, this is the measurements you can take while making the board, or you can buy some you can buy it also. Okay, you can change the measurement also. Skateboard are not as effective because it is difficult to maintain the straight line motion because it is moving. Okay, so this is the topic for third law of motion. Okay, in the next topic I will explain about conservation of momentum. Okay beta, thank you. आप अच्छे से कोशिश कीजिए. मैं आपके साथ कोशिश करूँगा आपको वीडियोस अवेलेबल कराने की और अच्छे से समझाने की. फिर भी आपको कुछ प्रॉब्लम है बेटा, कुछ समझ में नहीं है आता, कुछ सजेशन है, तो आप प्लीज़ मुझे बताइएगा ताकि मैं आपकी और हेल्प कर सकूँ. ओके, थैंक यू.